Hello everyone, as we already discussed about the speed in the first video, in this video we are discussing about the different two type of speeds which are there. The first term is basically the average speed. Now from the term average speed, it looks like that whatever the speeds are there, if we find the average, that comes out to be the average speed. Suppose a person A goes from this point to this point at a speed of 20 km per hour and he comes back at a speed of 30 km per hour. So what is the average speed of this man? Now from the question it looks like it is 20 plus 30 divided by 2 and comes out to be 25 km per hour. But this is a wrong perception and this is the wrong way of solving it, because the average speed, the formula is total distance divided by the total time. Now if we look at the same question, we can say that the distance we assume is x. If the distance is x, which he is going at a speed of 20 km per hour, then the time taken will be x upon 20. At the speed of 30 km per hour, he will come back x distance in the time x upon 30. So here we can say the total distance x coming and x going comes out to be 2x upon the total time will be x upon 20. This will be the time for coming plus x upon 30. This is the time for going back. So if we solve this calculation, it comes out to be 24 km per hour, which is not 25 km per hour. So the average speed is the total distance divided by total time. Here we can also apply one more logic, that instead of taking the distance to be x, we can take a value which is divisible by 30 as well as divisible by 20, to which we say LCM of 30 and 20, that is 60. Now suppose the distance is 60 kilometers. So 60 kilometers at a speed of 20 km per hour will take 3 hours to go from this to this place, and while coming back 60 kilometers he will take 2 hours. So the total distance will be 120 kilometers, 60 kilometers going and 60 kilometers coming back. So total distance will come out to be 120 kilometers and total time will be 60 upon 20, 3 hours in going and 2 hours in coming back. So if we solve it, it comes out to be 24 kilometers per hour. We can take another example of the same thought. Suppose there is a triangular distances and all these distances are same. Person goes from this point to this point at a speed of 20 km per hour. From this point to this point at a speed of 30 km per hour. And from this point to this point at a speed of 40 km per hour. So what is the average speed of this man? Now, if I say 20 plus 30 plus 40 upon 3 like this, that is the wrong solution. The right solution will be, because we know the average speed is total distance divided by total time, we can assume the total distance. We can take the total distance as x. So the total distance will become 3x. If I am taking the x distance from this point to this point, then this is also x and this is also x. The total distance becomes 3x and the total time becomes x upon 20. This is from A to B plus x upon 30 from B to C and x upon 40, that is from C to A, and then to calculate this. Again, if we apply our logic, then the LCM of 20, 30 and 40 comes out to be 120. So we can take the distance of one side from A to B as 120 kilometers. If I am taking the distance as 120, so 120 kilometer plus 120 kilometer plus 120 kilometer, we can say it is 360 kilometers. This is the total distance, this one. And the total time will be 120 kilometers at a speed of 20 kilometers per hour is 6 hours. Then 120 kilometers at a speed of 30 is 4 hours. And 120 at a speed of 40 is 3 hours. So the average speed becomes 360 upon 13 kilometers per hour. These way we can find out the average speeds when the distance is same. There can be two other type of questions which are there in average speed. In one of the question is the distance are different and the times are also different. For example, if A goes the first kilometer, 1 kilometer in 30 minutes, then the next 2 kilometers he is going in 45 minutes, and the next 3 kilometers again he is going in the same time 45 minutes from here to here. So directly we can say the average speed will become total distance upon total time. So here the total distance will be 1 kilometer plus 2 kilometer plus 3 kilometer, that is 6 kilometer, upon the total time will be 30, 45 plus 45, it comes out to be 120 minutes, and to this 120 minutes we can say 2 hours. So here the average speed will become 3 km per hour. If in case we look at the fourth type of question, there the distances are different and he is traveling at a different speed. For example, the first 60 kilometers he is going at a speed of 20 km per hour. The next 80 kilometers he is going at a speed of 10 km per hour, and the next 20 kilometers he is going at a speed of 5 km per hour. Then what is the average speed? Where the distances are different and the speeds are different. Again we can say, we know the formula, average speed is equal to total distance upon total time. So the total distance will be 60 plus 80 plus 20 comes out to be 160 kilometers. While the total time, because 60 kilometers at a speed of 20, from this to this portion he will take 3 hours. Here he will take 8 hours, and here he will take 4 hours. So the total time here they will take is 15 hours. And 160 kilometers when they are going in 15 hours, we can cancel by 5. It comes out to be 32 upon 3 km per hour. Now these are the different type of questions we can see in average speed. There is yet another term, that is relative speed. Relative speed, when we talk about relative speed, then there are two type of motions. One is known as independent motion, and one is dependent motion. When I am talking about independent motion, it means two individual bodies are traveling and the speed of this body does not apply to the speed of this, or the speed of this does not apply to the speed of this. Suppose this is known as the independent. Suppose here a train A is going in this direction and the speed is 20 km per hour. Here another train is going in this direction, the train B, and the speed is 30 km per hour. Now if this B will increase the speed or decrease the speed, then this increase or this decrease of speed of B will not affect the speed of train A. So these two are independent bodies and they are traveling either maybe in the same direction or they may be in the opposite direction. Like a man is running after a thief. So the speed of thief will not make any difference to the speed of man, or the speed of man will not make any difference to the speed of thief. So they can travel in the same direction, or these two people can travel in the opposite direction. So this is the examples of independent motion. And here we can say the question of trains will be applied. When we talk about the dependent motion, we can take the example of boats and streams, where there is a stream and there is a boat inside the stream. When there is a boat inside the stream, definitely when the speed of stream will increase or decrease, the speed of this boat will also be dependent on the speed of this stream. So this is known as dependent motion. There can be another example of escalator. When we go to the shopping malls, there are escalators, or you can say the moving staircase, where this staircase is also moving and the man is also either going in the upward direction or going in the upside or down direction. So here also there is a case of dependent motion, and here mostly the question of boats and steam has to be taken. This we will discuss further in our next videos on trains and the boats and steam.